Pong with App Game Kit Basic tutorial. That's what we'll do in this tutorial. We'll create a Pong game. Let me show you. It will look like this. It will have the basic functionalities of Pong. No UI, no nothing. The goal is basically to show you how to create a very simple game using App Game Kit Basic. In the media folder, we will only use one image placeholder, which is just blue rectangle with a gradient. So let's go to App Game Kit. After you create the project, that's the default code. With the title, the screen size and all that. No need to touch that unless you want to, like me, want to change the screen size to 500 on 768. So let's start. The first thing I want to do is create global variables that will hold the IDs for our images and sprites. In App Game Kit, when you want to manipulate an image or a sprite, you need to give its ID. It's a number, an integer, but I like to put it on a global variable, so I won't have to write a number like 1 or 2 or 2000. I just write what it is. If it's a ball, I write a ball. Its numerical value doesn't matter. Let me show you. IDs, global PH. PH is short for placeholder, so our placeholder image will have an ID of 1. Let's duplicate it a couple of times. We'll only have 4, so we'll have 1 for the ball. Its value will be also 1. Like the images and the sprites will have they have different IDs. Like you can have ID 1 for an image and ID 1 for a sprite and ID 1 for a button. It doesn't matter, it's just an ID for that specific object. So the placeholder ID will be 1 and the ball ID will be 1, 2. Pedal 1 for the player will be, its ID will be 2, and pedal 2 for the CPU, the computer player, will be 3. And that's it for the global variables. Load images. In our case, it's just one image. Load image. PH. Then first you give the ID of the image and then the source of the image. In our case, it's ph.png. The image I've showed you in media. This image. By default, when App Game Kit searches for a source, if you don't tell it in which folder it is, it assumes you mean media, which is nice. So I just write the name of the image and it searches for it in the media and loads it. And when I'll need to use it, I'll just call ph, which is 1. So let's create the sprites too. Create sprites. So the command is create sprite. You probably know this if you seen any other App Game Kit program or did any other tutorial. So it also takes two arguments. One for the ID, which is ball, and the other one is placeholder image. Both of their values are 1, but their meanings are different. Here I want the ID of the ball, here I want the ID of the placeholder. Like I am gonna use placeholder a couple of times, like 2 more times, and yeah, I don't need to write 1. I only need to put ph. You might not see the advantage if you're a total beginner, but let's say I change this ID to something else. Now I'll need to change it here, here, and here. But because the ID is on a variable, I only need to change it in one place. Like I can do this. That's the new ID. And it will be inserted here, 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 and here. And I only need to change it in one place. So yeah, that's why I create global IDs, so I can use them anywhere I want. So now that we have those sprites, it will load them at 0, 0, like 3 boxes at 0, 0, 0, 0 position. At the bottom, at the top left, you'll see in a moment. And it crashed for some... Oh, I know why it crashed. Do loop sync. And that's how you create a game loop with AppGameKit. Now it will work. You see it's at the top here. So let me show you in Paint real quick. The axis in computer graphics, GUI, whatever, goes like that. That's the x-axis, and that's the y-axis, and 0, 0 is like starts from here. That's 0, 0. Yeah, it's hard to draw with this mouse. So basically this point is 0, 0. Let's say this one is 100 on the x-axis and 0 on the y-axis. This one is 200 on the y-axis and on the x-axis. So by default they all start from 0, 0. So before I change their sizes, first thing I would like to do is to first set their positions. So set sprite pause. The command is set sprite position. Sprite pause. And it gets 3 arguments. The first argument is the ID. Let's do the ball first. Ball, it will be on 200 by 200, and let's do the 2 other sprites. And I see the error, that's okay. I'll fix it now. 2 commas. That will bring a nice error. Okay, now that's okay. So pedal 1, I want it to start from 10 on the x-axis and 0 on the y-axis, so it will start at the top. And this one will start from 460, the right side of the screen, the game screen, and 20 pixels from the top. Let's see how this will look like. Yeah, so that's the ball, that's the player, that's the computer player. Let's change the pedals so they look more like pedals. Pedal sizes. Now we'll need to give both pedals the same width and height, so we'll create 2 variables. Pedal width will be 20 and pedal height will be 70. So 20 pixels width, 70 pixels height for the pedal. Let's see, set sprite size. Set sprite size. This one also gets 3 arguments: the ID of the sprite you want to change, and the width and height. So the width is pedal width, the height is pedal height. Let's see what this will give us. Yeah, so now we have our 2 pedals and our ball. And what else should we do? We need two variables for the very basic linear algebra we'll do with the ball. We'll need the ball's speed and the ball speed on the x-axis and the ball speed on the y-axis. So we'll call it ball variables. Ball vars. So global, I make it global so I can access it from anywhere in my program. Ball speed x equals -5 and ball speed y, I want it to be just 5. So let me show you what this will do. It won't do anything, I just need to print screen this so I can show you on Paint what's going to happen. What is this for? So the ball speed on the x-axis is -5. Let's say if this is 5, so -5 will be here. But let's say this one is 200, so -5 will be 200 on the x-axis. So -5 will be 195, which is here. So every frame it will move 5 pixels to the left. And also it will move on the y-axis 5 pixels. If it was -5, it will go like up. Here is 200 on the y-axis, and here is like 205, 210, etc, etc. -5 will make it go up, 5 will make it go down. So its movement together in this direction and this direction will be like that. It will go here. So I'll have to move the pedal and if I want to hit it. And then when it hits the pedal, I want to multiply its x speed by -1. 5 multiplied by -1, it's 5, so it will move in this direction now. But it will continue to move down, so it will go like this. So to make things more interesting, I will randomize if it multiplies the speed of the y speed by -1. Like sometimes it will move down, sometimes it will move up randomly. You'll see in the code. Don't worry, you don't need to remember that. I'll show you when we get there. So for that, I'm not going to just spam code in the game loop. I'm going to create 2 functions. One function to control the pedal, like the pedal control will be both for the player and the computer, and ball movement. Let's write them. Function control pedal. Okay. So the other one I said was ball movement. Control pedal will get two arguments. One is the sprite ID, and the other one is it player controlled? Is P, is player. If it's player, control the pedal using the mouse. If it's not player, make it home on the ball automatically. You know, that's what the computer player does. So if is P, both of them are integers, by the way. This gets a number and this gets a number. That's the sprite ID, and that's that gets 1 or 0. In AppGameKit Basic, in AGK Basic, you don't have booleans like true or false. They use 1 and 0. So if is P is 1, this argument will be considered true, the ifs argument. Let's see, so player y, like if it's human player, get pointer y, and then set sprite. Let's just copy paste this. Set sprite position to the sprite ID we give it, and its x to its own x. So get sprite x sprite ID. Whatever ID we'll put here when we use the function will be used here and here. Here to say which sprite we want to change its position, and here to not change its x value, because this changes both x and y, this method. So the other one will be py. So basically what this does, if the pedal we want to control, the sprite of the pedal we want to control is the player, like this one is pedal 1 and this one is 1, do this code, which will get pointer y will get either the mouse y, or if it's a smartphone, wherever you clicked on the screen it will get the y position of the tap. Let's use it. Control pedal, so we want pedal 1, and it is the player, so 1. So this will basically do this. Now we can control the pedal. So yeah, in terms of what's happening, like if we click here, it will get the y of this position and will set this pedal's y to this position. That's basically what the code does. I hope you understand it. Like if you're a novice to programming, yeah, that's not really the tutorial for you, but most people that use AppGameKit already try to use different product, game framework, game engine. Yeah, for the second one we need pedal 2, and we want this to be 0, so it won't enter this if. It will go to the else. Let's see, by ball y, we want it to home on the ball. Get sprite y, and we need to pass it the sprite we want to get its y, which is the ball. So this will hold the ball's y position to basically get this y position, and we're going to make this this y be the same as this y, so it will be here. Let's do that. Set sprite position. Yeah, we'll just need to change one small thing here, not player y, ball y. So let's see what this will do. Yep, now it's in the same y as the ball, so if the ball moves it will follow its y and will always catch it when it reaches it. Nice. So let's do the ball movement. That part, yeah, it's a bit longer and with a little bit of linear algebra, but you'll see it's not that bad. So first thing, I want to get the ball x. Let's copy that to save some time. I basically want to get the ball x and y. because I'm going to manipulate them. Let's do, first thing we'll do is the collision detection. You know what, first let's do the movement before we do the collision detection, so you'll see the ball move. So the way we'll make the ball move is set sprite position, of the ball ID, ball sprite ID, and Vx plus ball speed x, and Vy plus ball speed y. So if we change the ball speed x and y, it will change its movement direction. The ball speed x and speed y is these two, -5 and 5. So if we change it to 5, it will move in the other direction, like when collision detection happens. Let's see it move, and you'll also see them. You see, the enemy pedal follows the ball. So let's handle what happens when it hits a pedal, either the player or the computer pedal. So it goes like this: if gets sprite collision pedal ID, and we need to give it the ball ID. So this one checks if a collision happens between the pedal 1 and the ball, and we'll need to have another argument, or pedal 2 hits the ball, or the ball hits the pedal 2. So if it hits the player or the computer player, do this, whatever inside and if. And I told you, it's quite simple. Ball speed x, the global variable, will equal ball speed x multiplied by 1. And let's do random y, random speed y. And I want it to be something a bit arbitrary, 1 to 10. So basically every time it hits, this will be a random number between 1 and 10. If it's bigger than 5, do something. So if y is bigger than 5, change the y speed. Then ball speed y equals ball speed y multiplied by -1. So sometimes when it hits a pedal, make it move. Let me show you. Sometimes when it hits a pedal, make it move down, and in the other times make it move up. But whenever it hits a pedal, change its x speed to go the other direction. Let's show you. Oh, that was an interesting bug, but it shouldn't happen again. Oh, it just goes through pedal 1. Interesting. Very interesting. It's the same code I used for the example I showed you. That's why I say it's very interesting. Bx, by, b speed y, b speed x. Is it called b speed x? Yeah. -1. Forgot the minus. Okay, now we have that mechanic. And it goes up because we don't have a boundary up and we don't have a boundary down. So we'll have to fix that so the ball won't be able to go that much up or that much down. But the collision works, as we can see. So let's do another if. If hits bottom or top. So if ball y is bigger than get screen bottom, so basically if the ball y is bigger than the bottom of the screen, like bigger than this, do something. And we want to do the same for the top, so we'll have to add a or to our argument, or ball y is smaller than get screen top. And if so, what I want to happen, if this happens, I want the ball to move to the opposite direction on the x and y speed vector. It's called, I think, what we do here is vector addition. We basically add the x and y vector to the speed xy vector. And let's see, and here I think it's multiplying a vector by -1. But you can use it without calling it linear algebra. It's good to learn linear algebra for game development. Forgot the parentheses. Now when it hits the bottom, it will do That's an interesting bug. And it should randomly go down at some point. Yeah, now this shouldn't happen every time. Very interesting. Let's see. So it changes the direction. Let's try this. Yeah, that's better. So apparently when we changed the x speed, it shot it back to this pedal, and then back to the wall, and then back and forth. So we don't need this apparently. Interesting bug. And as you've seen, when the ball exits the boundary to the left or to the right, it just continues. We want to fix that. We want to make it go back somewhere here. When this happens, we don't care about points or stuff like that. We just want to do the mechanics. So I don't want it to collide with this operation, so I'll do it here. Like after it moves, if it moves out of bounds or get out of screen, let's call it if it gets out of screen. So how can we tell if it gets out of screen? Basically, if bx is less than 0, if b the ball like is less than 0, x less than 0, x is here, like x0 is here, and then we'll have to check if x is bigger than this boundary. So it will be, we'll have to add an or bx is bigger than get bounds right. Screen bounds, sorry. Get screen bounds right. Then do something. Let's see, so if this happens, we want to set the ball sprite to a random position on the middle of the screen. So let's leave the by wherever it is, and instead of bx, let's change the ball x to random somewhere between 20 pixels to 200 pixels. Let's see what this will do. Let's miss the ball by on purpose. So let's do 50 here. We want to give the player some time to react. Okay, so when it won't exit from the other side because the enemy pedal is perfect. Oh, and check this out. If I change this to 1, now the player controls both of the pedals. You see? Now let's miss on purpose. Yeah. And we can also make both of them controlled by the computer. So the computer can play with itself by setting this to 0. So for both pedals, instead of going here, it will go here. And they go down for some reason. Well, I don't really care why they do that. I just wanted to create a simple working prototype of Pong and teach you very basic, very basic game programming. I just wanted to show you the mechanics of Pong. So we did it in 101 lines of code. 100 lines of code. Yeah. Let's see. So yeah, if you don't understand anything, you can send me a private message, comment on the video. I'll leave a way to contact me. But basically, it should be very simple to understand for someone that knows basic programming. Yeah, and that's it for this lesson. Next time I'll show you how to code another game using AppGameKit. And that's it.